Well, good afternoon, everybody, and welcome to this book launch of Oxford's Savilian Professors of Geometry, both to those of you here at Barnard's Inn Hall and those of you who are watching online. This book was published by Oxford University Press in January. And I was wondering how many of these 5 professors, Savilian professors, can you recognize? If you can't recognize them all, you should probably stay here, because today you'll be meeting all 20 of them, covering a period of 400 years. So the authors for this edited book are all acknowledged experts in the history of mathematics, and their chapters are illustrated by over 130 pictorial images, many of which you'll see today. And our journey begins with Sir Henry Savile's founding of his chairs of geometry and astronomy, as related by William Poole of New College, the Oxford College now associated with the Savilian chairs, and also of Oxford's history faculty. And also from the same faculty are Philip Beely and Benjamin Wardow, who have written on John Wallis, who was Savilian professor for over 50 years, as you'll see. Wallis's successor was Edmond Halley, or Hawley, of Halley's Comet fame, the first of a succession of astronomers as described by Alan Chapman of Wadham College and Chris Hollings of Oxford's Mathematical Institute and the Queen's College. These then take us to the Victorian period, where 3 Savilian professors, Baden-Powell, Henry Smith, and James Joseph Sylvester, are introduced by Keith Hannibus of Balliol College and Karen Parshall of the University of Virginia. Then, moving on to the 20th century, we meet G.H. Hardy and his successor, Edward Titchmarsh, while Frances Curwen, the current Savilian professor of geometry, has written about her doctoral supervisor, Michael Atiyah, and his successors. And Mark McCartney of the University of Ulster has interviewed her predecessor, Nigel Hitchin. Incidentally, Mark McCartney and Chris Hollings are currently editing a companion volume on Oxford's Sedleyan professors of natural philosophy. So here are the first 9 geometry professors, taking us through the 17th and 18th centuries and into the 19th. And a few of them, such as Briggs, Wallis, and Halley, would become familiar names, as you'll see, while some others are largely forgotten. So how did the professorship start? Henry Savile was born in 1549 and had an eventful career, eventually becoming both Provost of Eton College and Warden of Merton College in Oxford. The author of an 8-volume history of St. Chrysostom and other scholarly works, his first love was mathematics. And here you see his capacious Chista Mathematica, his mathematical chest for his books and manuscripts, now in the Bodleian Library. And on the right is his magnificent memorial in the antechapel of Merton College, where he is flanked by Euclid and Ptolemy, whose writings he expounded at Oxford. While below, you can see some handwritten lecture notes on astronomy, with Ptolemy's work on the left and Copernicus's then very recent work on the right. In 1619, Henry Savile founded his chairs of geometry and astronomy for persons of character and repute from any part of Christendom, well skilled in mathematics and 26 years of age. For the geometry chair, John Aubrey has recorded, as you see here, that Savile first sent for Mr. Gunter from London to have been his professor of geometry. So he came and brought with him his sector and quadrant, shown on the left, and fell to resolving of triangles and doing a great many fine things. Said the grave knight, Savile, "Do you call this reading of geometry? This is showing of tricks, man." And so dismissed him with scorn and sent for Henry Briggs from Cambridge. But Henry Briggs was by then in London as the first professor of geometry at Gresham College. Gresham College had been established to present free lectures to the general public, as it still does over 400 years later. And while at Gresham College, Briggs studied eclipses and navigation, and he later produced the map of North America that you can see on the right. He also became obsessed by the new and admirable logarithms of John Napier, shown here below on the left, designed to simplify calculations by replacing multiplications and divisions by the rather simpler additions and subtractions. And as Briggs enthused, "I never saw a book which pleased me better and made me more wonder." But Napier's tables were clumsy to use, and Briggs introduced his more practical logarithms to base 10, producing first the tables in the middle, and then in 1624, by which time he was in Oxford, he published the more extensive ones, the more extensive tables that you can see on the right. And these included the logarithms of no fewer than 30,000 numbers, which he calculated by hand to 14 decimal places. Certainly a prodigious feat of calculation. Briggs's gravestone, shown above, can still be seen in the antechapel at Merton College. Meanwhile, having failed to get Saville's geometry chair, Edward Gunter went to Gresham College as its professor of astronomy, while the Savilian astronomy chair was held by John Bainbridge, whom you see here, and his memorial, shown in the middle, is also in the antechapel of Merton College. Bainbridge wrote several notable works, including one on Ptolemy's planetary hypotheses, and this one on the right is Canicularia on ancient Egyptian astronomy. After Briggs and Bainbridge, the Oxford chairs were occupied by two people, Peter Turner in geometry and John Greaves in astronomy. Greaves had actually previously been the Gresham Professor of Geometry here in London, and succeeding Turner in that position. Turner had held it earlier following Briggs. Who were these people? Well, Turner was described by a contemporary as a most exact Latinist and Grecian who was well skilled in Hebrew and Arabic, was a thorough-paced mathematician, a most curious critic, a politician, statesman, and whatnot. But his mathematical writings, if there were any, have not survived. Primarily a university politician, he designed this weekly chart that presented the university's syllabus for the liberal arts. An ardent royalist in the Civil War, then raging, Turner was later imprisoned, and his loyalty to the royalist cause cost him his career. John Greaves, on the right, was a more impressive figure who was proficient in many fields. He studied Oriental languages and collected ancient manuscripts. He also acquired astrolabes and other mathematical instruments to take on his extensive travels in Europe and the Middle East. And while in Egypt, he entered the Great Pyramid of Cheops to measure its inner chambers, and described his experiences in his memorable book, Pyramidographia, shown below on the right. But the English Civil War was raging, and by 1649, the royalist professors had been replaced by supporters of the parliamentary cause. Peter Turner was succeeded by John Wallis, who had shown exceptional service as a codebreaker for the parliamentarians. But as Wallis admitted, in the year 1649, I moved to Oxford, being then public professor of geometry, of the foundation of Sir Henry Savile. And mathematics, which had before been a pleasing diversion, was now to be my serious study. But although Wallis had little mathematical experience before his appointment, he soon made up for lost time, as you'll see. And here, on the left, you can see a 1678 engraving on him, and on the right is the magnificent portrait by Godfrey Kneller that now hangs in Oxford's examination schools. Wallis held the geometry chair for 54 years, the longest tenure of any Savilian professor. And here on the left is his inaugural lecture given in the geometry schools in October 1649. While on the right are two items from his first important book, a treatise on conic sections, the ellipse, parabola and hyperbola, his treatise on conic sections published in 1655. And it is here that we see the first appearance of the symbol that we now use for infinity. You can just about see it at the end of that arrow. While below is his use of Cavalieri's ideas to calculate areas. And the very next year, 1656, Wallis produced his best-known work, The Arithmetic of Infinities, where he solved several area problems. And among the many achievements here was his infinite product for pi, which you can see above, where the small rectangle you see there represents 4 over pi. And it was obtained using interpolation. It was carried out in his table below. But John Wallis was not an easy man to get on with, and he became involved in several disputes, such as those with the philosopher Thomas Hobbes, whose attempts to solve various classical problems, such as squaring the circle, were described by Wallis, in the work on the left, as inept. Hobbes then replied, attacking Wallis in the acrimonious work on the right. And Wallis then retaliated, and so on. And their rivalry continued for almost 25 years until Hobbes' death. Wallis's later publications included a treatise of algebra, both historical and practical. It contained the earliest discussion of algebra's history, although from a very English point of view. He even accused Descartes of plagiarism. And on the right is his collected works, published in 3 volumes by the Oxford University Press, which was then housed in the newly built Sheldonian Theatre, which you can see below. So after 54 years, Wallis died in 1703, and his successor was Edmond Halley, shown on the left in his youth and on the right in his old age. He was an undergraduate at Queen's College, and below is his signature in the college register. And although we know him mainly as an astronomer, it was Saville's chair of geometry which he came to occupy, and he occupied it for almost 40 years. Halley had varied interests. While still a student, he sailed to St. Helena to map the skies of the southern hemisphere to a greater accuracy than previously, which secured him an international reputation and election to the Royal Society at the age of just 22. It also led to King Charles II commanding Oxford University to award Halley an MA degree without examination. Halley's interest in magnetism led to him producing the magnificent chart of magnetic variation that you can see here on the left, where he introduced the now familiar idea of joining points with equal values. Later, in 1715, a solar eclipse in England led him to send the map on the right around the country in order to solicit local observations. The Savilian chair was actually Halley's first academic post. And to establish his credentials, what did he do? Well, following a widely admired inaugural lecture on geometry, he secured his academic reputation by producing what became the definitive edition of the ancient text on conics by Apollonius. And its frontispiece, that you can see here on the right, features the image first introduced by Saville, which shows the Greek philosopher Aristippus, who, having been shipwrecked on the island of Rhodes, was assured of the local inhabitants' civilized nature when he discovered mathematical drawings in the sand. And in fact, there are several books published by Oxford University Press which have this picture, one by Saville, this one by Halley, there's another one in between, and they all had different mathematical drawings depending on the contents of the book in hand. So Halley lived at this house in New College Lane, on top of which he built an observatory which a contemporary described as very convenient and indeed useful to the university, and what Sir Henry Savile did expect from them. Indeed, these two adjacent buildings housed the two Savilian professors for some 200 years. In 1720, Halley was appointed Astronomer Royal, and for the last 20 years of his life, he spent much of his time at Greenwich, while continuing to hold his Oxford position. That was allowable in those days. And his house, the one in white, now marked with a plaque, you can see below. It used to be marked with the plaque in the middle, where Edmond was incorrectly spelt, but now that's been replaced by the one that you see on the right, which was unveiled about 3 years ago. And his house is currently used for housing the college's undergraduates. Halley was, of course, an astronomer, in fact, the first of several astronomers to hold the Savilian chair of geometry. And his successor was Nathaniel Bliss, who also became Astronomer Royal, but late in life, giving him only 2 years at Greenwich. The left-hand image that you can see here wrongly calls him Professor of Astronomy. Nathaniel Bliss, AM, Professor of Astronomy in Oxford. Where does that come from? That engraving, it was engraved on a pewter mug during a rather exciting dinner. Bliss took his professorial duties very seriously and lectured on a range of topics, in fact, ranging from algebra and geometry to the use of logarithms and surveying instruments. Although one student, actually the teenage Jeremy Bentham, claimed that almost all Bliss's practical experiments in his lectures tended to go wrong. By this time, Isaac Newton had died, but Oxford teaching was already becoming very influenced by his ideas. And here's a course of mathematical lectures and experiments based on Newtonian principles, all in great details there, and Bliss's teaching was along similar lines. Another Oxford Newtonian of the time was John Desaguliers, whom you can see shown at the top. His fine drawings and expositions of experimental philosophy helped to popularize Newtonian physics. And this is just one of several beautiful plates showing scientific diagrams. So that was Nathaniel Bliss. But we know rather little about the next two geometry professors. Joseph Betts, another astronomer, was also interested in eclipses, as his diagram of the 1764 solar eclipse shows. But he died after only 1 year in post. His successor, John Smith, occupied the chair for over 30 years, but he seems to have had few, if any, mathematical credentials. A physician for the new Radcliffe Infirmary, he spent much of his time practicing medicine in Cheltenham, while others carried out his Oxford lecturing duties. And here's his observations of the use and abuse of the Cheltenham waters, proudly presenting him as Savilian Professor of Geometry in the University of Oxford. The last two from our first batch of geometry professors were active in mathematics, although, again, mainly interested in astronomy. and in fact both of these subsequently switched over to the Saville Astronomy Chair. But Abraham Robertson's geometry lectures, incidentally, Abraham Robertson was one of the ones who filled in for John Smith when John Smith was looking at the waters of Cheltenham. Robertson's geometry lectures were popular, and he published on Euclid, and also, as you see here, on conic sections as an introduction to the Newtonian philosophy. While his successor, Stephen Rigaud, shown here in silhouette, wrote on a range of topics from Archimedes to steam navigation. So we now move to the second batch of geometry professors. We've now reached the 19th century, and we look next at the Victorian period, which is represented by 3 Savilian professors, before proceeding to the 20th century and beyond. So the 10th geometry professor was Baden-Powell, who occupied the chair for over 30 years. And if his name seems familiar, it may be because one of his sons founded the Boy Scout movement. I think it was his 6th son by his 3rd wife, but I'm not quite sure. And here you can see 3 images of Baden-Powell, including the early photograph on the left, which was taken around 1850. Baden-Powell's career took a common progression at the time, getting a first-class degree, in his case at Oriel College, followed by a college fellowship, leading to ordination and a college church living. So Powell became a vicar in London, where he spent his spare time researching into the polarization of light. And this led in turn to a fellowship of the Royal Society, and eventually to his Savilian appointment in Oxford. But Oxford mathematics at this time was at a very low ebb, with poor standards and small student numbers. And on his arrival, Powell was warned off giving an inaugural lecture because no one was likely to attend it. So instead, he produced 2 publications, a pamphlet that you can see on the left, on the present state and future prospects of mathematical and physical studies in the University of Oxford, where he argued the importance of these studies as part of a liberal education. And on the right, a history of natural philosophy, which was designed to promote general scientific awareness. And in truth, Powell was not primarily a mathematician, but rather a popularizer of science. And here you can see him at London's Royal Institution giving a public lecture in 1851 on the rotation of the Earth. While here, the upper picture, both pictures are from Oxford's second meeting of the British Association for the Advancement of Science. That started in 1831, I think, in York. The second meeting was in Oxford. And Oxford's second meeting was in 1847. And here at the top, you can see it shows Baden-Powell in Oxford's Radcliffe Camera giving a 2-hour lecture on falling stars. And also attending the same meeting were John Couch Adams and Leverrier, the 2 recent discoverers of the planet Neptune. And the lower picture shows Adams lecturing on this achievement. Well, Baden-Powell was a supporter of Darwin's theory of evolution, but died in 1860 shortly after writing a controversial religious article that impressed Darwin but alarmed many others. And his successor in the Savilian chair was Henry Smith, whom you can see here. Henry Smith of Balliol College, the first real mathematician to hold the post for well over a century. And on the right is a lovely student caricature of him. A highly popular figure, Henry Smith spoke several languages and was well informed on a wide range of subjects. And he held several college and university positions. And one of his positions was as keeper of the University Museum, which had been constructed in the 1850s. As you can see here on the left, there you can see the University Museum being constructed in the mid-1850s. There it is complete. This was at the time of a big scientific meeting. There you can see the keeper's house in the middle at the top. And he lived there with his sister. And the bust of him, just next to there, can still be seen in the University Museum. And there below is an engraving, a drawing of the university, the interior of the University Museum. Henry Smith's mathematical researches covered a range of topics, from matrix algebra, where he introduced the so-called Smith form of a matrix, to the theory of integration, where he presented a form of Cantor's ternary set 8 years before Cantor got there. But maybe his most important contributions were in number theory, the theory of numbers. And here is the first of 6 major articles on the subject that he wrote for the British Association. Smith's work on number theory included the problem of counting the ways in which we can reach a given number by adding perfect squares. For example, if we're given 11, you can write it as a sum of 5 squares by taking 9, 2 1s, and 2 zeros. Or you can take 2 4s and 3 1s, or any rearrangement of these. And Smith wrote a paper counting the number of ways of sums for 5 squares and also for 7 squares. The problem had been solved for other numbers of squares, but 5 and 7 were the two that no one had been able to do until he came along. So imagine his consternation then when some years later the French Academy of Sciences posed the 5 squares problem as its special yearly prize competition. Smith wrote to the competition chair, Charles Hermite, you can see in the centre, pointing out his priority. Hermite was rightly greatly embarrassed and urged Smith to submit his solution in French, which of course Smith knew. But sadly Smith was unwell and he died before completing that task. And the prize was eventually shared between him, posthumously, and a young German, Hermann Minkowski, on the right, who had reached similar conclusions and who later became a well-known mathematician in his own right. Henry Smith was succeeded as Savilian professor by James Joseph Sylvester, who held a number of positions in England before becoming the first professor of mathematics at the newly founded Johns Hopkins University in America. But as a Jew, Sylvester had been barred from receiving his Cambridge degree in the 1830s, or from holding any academic post in Oxford or Cambridge. But in 1871, the rules changed, and so Sylvester, writing from Baltimore, he successfully applied for the Savilian chair, and he was appointed at the advanced age of 69. Earlier, Sylvester had worked with the Cambridge mathematician Arthur Cayley, especially on a subject known as invariant theory, and the two became firm friends. But Sylvester soon became disillusioned with Oxford, as the research community that he developed in Baltimore did not exist in Oxford, where the emphasis was almost entirely on undergraduate teaching. And as Sylvester complained in this letter to Cayley, he says, "I am bound by usage and by the wants of the undergraduates reading for moderations to give a course or courses of lectures on pure synthetic geometry. Indeed, as the professor of geometry, Sylvester had to give regular lectures on that subject. And one of his ideas was for a course of lectures on surfaces illustrated by plaster, string, and cardboard models, to be accompanied by three-dimensional models, such as the one you can see on the right. He no doubt came across these models by Ludwig Brill of Germany, and here you can see a laboratory at Johns Hopkins University in Baltimore with lots of these models there in the cupboards there. But unfortunately, the models didn't arrive in time for his lecture course. So instead, he lectured on Tuesdays and Saturday afternoons, that wouldn't be popular now, on projective reciprocants and their geometrical applications, a topic from invariant theory. Well, the models eventually arrived, and they still exist. They're actually housed in the Mathematical Institute in Oxford. But few undergraduates attended his lectures, as they were of no help with their university examinations. However, Sylvester did manage to promote mathematical awareness by founding the Oxford Mathematical Society, and this soon became the main forum for research activity in Oxford. Founded in 1888, here you can see a list of the first members, it met for many years, right up to the 1970s. On the right, you can see Sylvester as president, and the secretary was Edwin Elliott, an algebraist who later became the first Waynflete professor of pure mathematics. And below them are the two vice presidents, Bartholomew Price, Sedleyan professor of natural philosophy, and sometime mentor to the Oxford mathematician Charles Dodgson, better known as Lewis Carroll. And also you can see William Essen, who became deputy professor when eyesight problems prevented Sylvester from carrying out his Oxford duties. It was around 1892 that Sylvester found he couldn't lecture anymore. He came to London, and Essen continued as his deputy professor. Following a brilliant undergraduate career, Essen had been appointed a fellow of Merton College shortly after graduation, and was responsible, with Henry Smith and others, for reintroducing the intercollegiate lecture scheme that would replace college-based lectures. Up to that time, the professors lectured in their own colleges and the students went there. Otherwise, students would have all their teaching done in their own colleges. And it was through Essen and Smith and so on that the intercollegiate system that we know now came in. Most of Essen's academic contributions were not actually directly in mathematics, but were of its use, in particular in chemical kinetics. And after Sylvester's death in 1897, Essen was appointed his successor. His period as Savilian professor was uneventful, and he died in 1916 during World War I. So as a result, his successor was not in post until after the war. And this was Godfrey Harold Hardy, the greatest British pure mathematician of the first half of the 20th century, with particular interest in analysis, mathematical analysis, and in number theory. Although he's mainly remembered as a Cambridge man, he spent his happiest years in Oxford, as he said, producing in 11 years no fewer than around 100 papers, many with his longtime collaborator, J.E. Littlewood. And here you can see two pictures of Hardy. If you look at his mathematician's apology, which I'll show you in a minute, there's a long introduction by C.P. Snow, who says that, in fact, he only knew of five photographs of Hardy. Hardy didn't like being photographed. Well, I know of at least 14, and here are two of them, neither of them, I think, known to C.P. Snow. But why did Hardy leave Cambridge? After 5 years of close collaboration at Trinity College with the brilliant Indian genius Srinivasan Ramanujan, shown on the left, the latter had fallen ill and returned home, leaving Hardy devastated. Also, disgusted by the pro-war attitudes of the Trinity Fellows, especially in their treatment of the young lecturer Bertrand Russell, shown in the middle, Hardy needed a change of scene. Administrative tasks are becoming increasingly irksome, and his work with Littlewood, shown on the right, was going through a bad patch. So Hardy applied to Oxford and duly took up the Savilian chair in early 1920. As I mentioned earlier, these positions had for some years been linked to New College. And here's a 1920s view of the college. Hardy's rooms were in the block, the new block at the top of the picture. A true college man, Hardy enjoyed the atmosphere of the senior common room and was often the life and soul of the party, getting all his colleagues to play all sorts of clever games, which some of them enjoyed. Hardy's inaugural lecture was given in May 1920 on some famous problems from number theory, and in particular, he'd become interested in what's called Waring's problem. Some famous problems of the theory of numbers, and in particular, Waring's problem. It had long been known that every number can be written as the sum of 4 perfect squares, or as the sum of 9 cubes, or 19 fourth powers. But can you carry on in this way? Can similar statements be made about higher powers? And if so, how many of those higher powers are needed? Well, together with Littlewood, Hardy published no fewer than 8 papers on this subject. Indeed, in total, these two, Hardy and Littlewood, wrote almost 100 joint papers, causing a contemporary to remark, "There are only 3 English mathematicians, Hardy, Littlewood, and Hardy-Littlewood." And this picture taken in Cambridge seems to be the only one of them together. Well, Hardy disliked tutorial teaching, but he loved lecturing. And as a professor of geometry, he gave at least one course of geometry lectures every year, as well as giving a range of other things, number theory. He gave a course of mathematics for philosophers and all sorts of other topics. And he also much enjoyed supervising research students. In the 1920s, doctoral degrees were being introduced in Oxford, and Hardy had several students who later became well known. These included his Savilian successor, E.C. Titchmarsh, whom we'll meet in a moment, and Edward Wright, with whom he wrote a celebrated book on number theory, and who later became Vice-Chancellor of the University of Aberdeen. Hardy was also a strong supporter of women's education, and you can see him here with his doctoral student, Mary Cartwright, who later became mistress of Girton College in Cambridge and was the first woman to become president of the London Mathematical Society. As you can see, one of Hardy's main recreations was cricket, and here we see him leading out a cricket team consisting mainly of his research students during the 1926 British Association meeting in Oxford. Hardy described this photograph as mathematicians versus the rest of the world. A firm internationalist, Hardy worked with others to rehabilitate continental mathematicians after the war. In particular, he was active in the Rockefeller Foundation scheme for enabling international scientists to work abroad, and he hosted some of these in Oxford. In particular, these included the Hungarian mathematician George Polya, shown here, who visited England for 6 months with Hardy, followed by 6 months in Cambridge with Littlewood. And an outcome of these was their co-authored book on inequalities. But in addition to his 300 papers, Hardy also wrote several books, including a very influential course on pure mathematics, and also his well-known retrospective, A Mathematician's Apology, written in 1940, where he describes himself as a mathematician towards the end of his life. And the Mathematician's Apology should really be read by all students of mathematics. It is highly recommended. Whether you agree with what he says or not, it is something that everyone should read. He also co-edited Ramanujan's collected papers. Ramanujan, as I said, had gone back to India and tragically died in 1920 at the age of just 32. While in Oxford, Hardy became president of the London Mathematical Society and also of other societies. And here is the top of the beginning of his presidential address to the Mathematical Association on what is geometry, in which he insisted that I do not claim to know any geometry, but I do claim to understand quite clearly what geometry is. An interesting distinction. In 1931, Cambridge's Savilian chair, very prestigious chair, became vacant, and Hardy decided to return there, not least because he could then live at Trinity College forever, rather than having to give up his new college rooms upon retirement. So over he moved to Cambridge, and his Oxford chair was taken by his former research student, Edward Titchmarsh, who heard about the position only by chance, happening to bump into an Oxford mathematical colleague in the street. He said, "Oh, have you applied? The deadline's tomorrow." And also Titchmarsh stipulated that if appointed, he could not undertake to lecture on geometry. And his application was only a page long and sort of done rather roughly. But anyway, he was appointed, and the requirement to have to lecture on geometry was duly dropped, and the Savilian professor of geometry can now come from any area of pure mathematics. Here are two letters sent to Titchmarsh. The first, on the left, from the University Registry, is his appointment letter as Savilian professor, which I obtained a picture of from the Titchmarsh family. On the right is a letter sent to him on a problem in analysis by G.H. Hardy. Dear Titchmarsh, and then he goes straight into the problem, no preamble. Like Hardy, Titchmarsh published several influential books in addition to his many research papers. The first was a short monograph on the Riemann zeta function, which he later expanded into a major book. Another was his theory of functions on real and complex analysis, which I studied for many long hours when I was taking finals. And this book was once described as the rebellion of a young, widely read professor against the narrow range to which mathematical analysis was then so often confined. It didn't excite me quite as much as it did the writer of that, but even so, it helps me take my finals. But Titchmarsh's method of writing books was rather unusual. He would research a topic for a few years and then sign off by writing a book on it. And then he moved on to a completely different area and repeated the process. But in January of 1963, Titchmarsh died suddenly and unexpectedly, and his place was taken by Michael Atiyah, later Sir Michael Atiyah. Larger than life in personality, he occupied the chair for 5 years, and he was a genuine geometer with a wide interest also in other areas. Atiyah worked with many distinguished mathematicians from around the world. Here are 3 of his collaborators, whose names will be known to mathematicians: Friedrich Herzebruch from Germany, Isidor Singer from the US, and Raoul Bott, a US citizen of Austrian-Hungarian descent, and all of them visited him in Oxford, sometimes for extended periods of time. Work with Hirzebruch led to the development of an area of mathematics known as K-theory, and also with Singer to the so-called Atiyah-Singer index theorem, for which they were jointly awarded the prestigious Abel Prize, an equivalent, if you like, of the Nobel Prize, in 2004 by King Harold of Norway, as shown below. Many years earlier, in 1966, Atiyah had received a Fields Medal, the International Award for Mathematicians under the age of 40, and the top picture recalls the 3 Fields medalists who coincided for a while at Oxford. 2 others, Simon Donaldson and Daniel Quillen. Michael Atiyah was knighted in 1983 and received the Order of Merit in 1992. He finally left Oxford in 1990 to become simultaneously Master of Trinity College, Cambridge, Director of the new Isaac Newton Institute there, and also President of the Royal Society. In 1969, Atiyah's place as Savilian professor had been taken by the topologist Ewan James, who was in post for over 25 years. Following in the footsteps of his Oxford doctoral supervisor, Henry Whitehead, he quickly achieved an international reputation for his work in topology, and he wrote and edited many influential books and papers on the subject. And this bust of him at the top is in Oxford's Mathematical Institute. Incidentally, his supervisor, Henry Whitehead, that you can see top right, he was also a pig farmer who claimed to get the mathematical inspiration for his theorems by scratching the backs of his pigs. He was always in the Mathematical Institute in the morning, then at lunchtime he went back to the farm, scratched the backs of his pigs, and wrote his mathematical papers. I always said that the Oxford Mathematical Institute should have a permanent pig there, but that hasn't been taken up. On Ewan James's retirement in 1995, Richard Taylor was appointed. 2 years earlier, Andrew Wiles, you can see below, had presented a proof of Fermat's last theorem that the equation x to the n plus y to the n is z to the n has no positive integer solutions if n is at least 3. But unfortunately, there turned out to be a gap in the proof, and it was Richard Taylor who collaborated with Wiles to fill this gap. But unfortunately, Richard Taylor stayed in Oxford for only a year, leaving to take up an appointment at Harvard University. So we come finally to the most recent Savilian professors, Nigel Hitchin and Francis Kirwan. I won't say much about them, except to remark that Nigel held the position for 20 years and was interviewed for the book, and that Francis, who wrote the chapter on Michael Atiyah, her doctoral supervisor, and who also wrote the book's foreword, is still in post, having now held it for almost 5 years. And very appropriately, Francis was recently awarded the Royal Society's very prestigious Sylvester Medal, named, of course, after one of her Savilian predecessors. So to conclude, our book on the Savilian professors of geometry is now available from Oxford University Press and can be ordered from them online. But for more general information about mathematics in Oxford over the past 800 years, and not just the Savilian professors, please see the book Oxford Figures, edited by John Favell, Raymond Flood, and myself, with this edition published in 2013. And finally, may I thank you for listening. Thank you.